Today in 6.4, we're going to be focusing on something that I highlighted in 6.3. So going back to 6.3 real quick, that was the example that we had kind of used to guide us, said that the Gallup poll surveyed 1,523 people and asking if they had bought a lottery ticket in the last 12 months. And they had received a certain percentage of people saying yes, that they did. But one thing that was pointed out that, again, that I highlighted was that statistic can change from sample to sample. On 6.4, we're going to talk more about that idea, which is called sampling variability. Variability refers to the differences that can occur from sample to sample. So when you see the word variability, think of the root word there, which is vary, which means change. And so as we know, the more samples or the bigger samples that you can get will be better predictors for your entire population. Okay. But what I want to look at is we're going to re-talk about that sample that we took in 6.3. So it says a Gallup poll took 1,000 different samples of size 100, asking the same question as before. Again, that question was, have you bought a lottery ticket in the last 12 months? It says the first sample had 56 out of 100 people answered yes. The second sample had 46 out of 100, and so on. Okay, so here's kind of a visual of what this looks like. So the parameter, so if we're the lottery, their goal is that 60% of the population buys a lottery ticket every 12 months. Okay, and again, here was one sample's results that said that 56% said yes. Here was another sample that said 46%. Here was another sample that said 61%. And again, so on, with the idea being that each sample of 100 people got slightly different results. So they took 100 samples, and here's a breakdown of this. So we have a histogram here. And as you can tell, this histogram kind of follows that normal curve idea. And so just the way that you would read this histogram, on the x-axis would be the statistics, the number of people that said yes in each sample. And then the y-axis is the number of samples that were taken. So if I were to read this, it looks like 55% is right here. And that bar is right at about 100. So what that means is that there were 100 samples where 55% of people said yes. Okay, remember, they took 1,000 total. So of that 1,000, 100 of them included 55% of people saying yes. Okay, or I guess that's kind of a range. So maybe 54 to 56% of people saying yes. Okay, and then if I look at the next bar, that's a little bit above 100. So let's just estimate that as like maybe 125 or so. But 125 of the surveys had between 56 and 58% of people say yes, and so on and so on. And so what this does is that this will allow us to get a better estimate of what the population thinks. And again, the parameter for the lottery was 60%, and notice where the biggest two bars are, right at that 60%, or right around 58 to 62% happened about 100, or excuse me, with both the bars combined, about 300 times. And so again, even though each sample was different, it looks like a majority of them are falling in that 60% range. So here's kind of another picture of, again, just kind of the same idea. So here's 1,000 different sample sizes of 1,523. Here's what we were just looking at, the 1,000 different samples of 100. Notice the difference in the graphs. And again, it goes back to the idea that the more people that you can survey, the more accurate results you're going to get. So in this topic case here, we surveyed a lot more people. We still only took 1,000 samples, but every sample included 1,523 people. So because there are so many more people included, notice that the variability in our graph has completely changed. And once again, the parameter is 60%, and notice where the tallest bars are. By far and away, the tallest bars are between that 58 and 62%, so right kind of in the middle there. Okay, and again, notice the variability. When I look at this, it was a lot more spread out because the samples were a lot smaller. And the smaller the samples, the more variability you're going to get. In this case, the samples were a lot bigger, and so there's a lot less variability. Now, this still follows kind of that normal curve shape, but again, it's just not as spread out as the 100 sample or the 100 sample size was. Okay, and so again, the more people, whether it's taking more samples or whether it's taking a sample with more people or a combination of both, but the more people that can be involved in a sample, the more accurate your data is going to be. And that would probably be the biggest takeaway here, is to understand that, but then also understand that there can be some change, there can be some variability from sample to sample. Okay, I'm going to give you a kind of another visual of this, but in this chapter and in previous chapters, we've been talking about bias. Remember, bias is consistent, repeated deviation of the sample statistic from the population parameter in the same direction when we take many samples. Remember, bias is not a good thing. Okay? Bias is a bad thing. We do not want any bias when we take samples. Okay? And so one way to identify a bias, again, is taking many different samples, but getting results that are not in line with the parameter. Okay. And again, we talked about variability, describes how spread out the values of the sample statistic are when we take many samples. So a good sampling method has both small bias and small variability. Okay. So here's, again, it's just kind of I think it's a good visual of the different types of things you can have. So, and it pictures it for you. So in example A, this kind of bullseye has high bias and low variability. Okay, so if we're aiming for the middle, notice that all of our bullet points or our data points are all falling in this cluster. Okay, so that's why it's high bias, because they're all falling. It's a repeated deviation from what you're trying to do, which is to get into the middle. And there's low variability because they are all clustered together. Okay. Example B, low bias and high variability. So again, not a lot of bias because it's just completely random. Okay. Again, bias is a consistent repeated deviation of the sample statistics. So this is not repeated because it is so random and it's spread out on the I just kind of call it a dartboard. But it's high variability because all the darts or all the spots are so different. They're in such different locations. Example C, high bias and high variability. So again, there's a lot of variability here because they're all spread out. But if I think of this dartboard as quadrants, they're all in this kind of upper right-hand quadrant. So then there is bias there. Okay. And then again, this is the ideal where there's low bias and low variability. This is what we're aiming for. And so let me go back and talk about, use the idea of that. I actually still have it pulled up here. This example here, where we talked about the goal of the TSA is that 10% of passengers get screened. Okay. And that on that particular flight, there was only 8%. So if I use that example here, again, the bullseye, the middle is 10%. Okay. And what these all represent is different types of variability and bias. And so, in this case, in this example A, what we're seeing is that there could be a higher statistic. Remember, the parameter is 10%. The statistic is the actual sample. So maybe people flying to a certain place are getting tagged more than others. Again, in this case, the sample is the different people on each flight. So maybe a flight to Chicago, just to pick a place, has higher a higher percentage of people that were screened on average than a flight to Nebraska. Okay. And so that's kind of it's just the idea of what's happening here, or what this is trying to depict is statistics that don't match parameters. Remember, the parameter is kind of the goal result. So again, the TSA has a goal that 10% of passengers are randomly screened, but that's going to be different from airplane to airplane. Okay. So again, using random sampling and large sample sizes will reduce bias and variability. And this is kind of what we've been talking about in the first section. We're going to learn a couple more methods moving on in chapter 6 is how we can make a truly random sample. Okay. So in 6.4, you will be looking at identifying and just practicing this idea of bias and variability. Okay. Have a good day.